we need to conclude the concept of threads and we need to start the discussion of memory management. So before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. So if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If able to recollect, what is the discussion happened in the last session? In the last session, we are trying to understand a little bit more about the thread concept. We are trying to understand some arguments in the thread. My question is, if main thread is creating one thread using pthread underscore create, so what is the significance of the fourth argument here? What is the significance of the fourth argument here? Again, when main thread is creating the subthread, third argument is a function pointer, means which function you want to register as a thread, that function address you need to pass it as a third argument. But what is the significance of fourth argument? Answer is, if main thread wants to pass some information to subthread, yes, main thread wants to pass some information to subthread via this fourth argument, it can pass it. Whenever you are creating any thread, what will be the function prototype? Whenever you are creating any thread, that thread function, what is the return type? That thread function, what is the return type? Can I say it is a void star? Function name. What is the argument? What is the argument? What is the argument? Can I say that is also void star? Yes. One more thing. What is the return type of pthread underscore create? Upon success, what it will return? Upon failure, what it will return? Upon success, what this function returns? Upon failure, what this function returns? Can I say 0 on success, error number on failure? 0 on success, error number on failure. Now my question is, suppose main thread is created a subthread and this subthread wants to send information to the main thread. How the subthread can send? Again, main thread is creating the subthread and subthread wants to send some information at the time of exit. Will you agree? It need to use pthread underscore exit. And here in the main thread, which function I need to wait? Through which function I can collect that information? Can I say pthread underscore join? Can you tell me what is the second argument of pthread underscore join? Address of a pointer. Will you agree? You need to pass an address of a pointer, because in a prototype you might have observed, double pointer there. In a prototype, if there is a double pointer, in the last session whatever we discussed, we are passing the address of the a pointer. That type of discussion happened. And one more thing, in the last session we achieved something called full duplex communication between the two processes. In this one thread, another thread, and this is the main thread. This is one thread, this is another thread, this is the main thread. This thread job is to scan the data from the keyboard, put it into F1 FIFO. This thread job is to read from the F1 FIFO, print it on the screen. This thread job is to scan from the keyboard, put it into F2 FIFO. This thread job is to print it on the screen. Now here, this thread is in a while one, this thread is also in a while one, this thread is also while one, this thread is also in a while one. External world recognizes this as the two processes. External world recognizes this as the two processes. But total how many threads involvement is there to achieve this task? External world recognizes that as the two processes, but total how many threads are there in this to achieve this task? Can I say 4 threads are there? I hope that's what we discussed in the last session. So today's our discussion will be thread synchronization using mutex. So today's discussion is thread synchronization using mutex. Again, I'll read the statements here. Thread synchronization using mutex. Can anybody tell me why we need a synchronization between the threads? Can anybody tell me why we need a synchronization between the threads? Will you agree? The advantage of the thread is if threads wants to communicate, they can communicate using the global array. The advantage of the threads is if the thread wants to communicate, they can communicate using the global array. Similarly, the drawback is also there, disadvantage is also there. Observe here, observe here, observe this program, header.h. Now will you agree? This is a global array. Will you agree? I declared one character array of 200 bytes. Can I say it is stored in a data section, which is a common for all the threads which we are going to create in this process, which is a common for all the threads which are going to create in this process. As a C programmer point of view, when you think it, this array can be accessible in this entire file as well as in another file. As a C programmer, if we think it, this array can be accessible in this total file as well as in another file. Listen, what is the storage type of this? What is the storage type of this? It is not an auto. Compiler will assign static properties with external linkage. Global variable. Global variable. Compiler will assign static properties with external linkage. Now observe. Void star thread underscore 1 void star p void star thread underscore 2 void star p void main. Now how many functions here you are observing in this code? How many functions? Can I say 3 functions? thread 1, thread 2 and main. Suppose main is creating these two threads. I'm writing the rough code. I'm not writing the exact code. Pthread underscore create address of T1 0 thread underscore 1 and 0 pthread underscore create address of T2 0 thread underscore 2 comma 0. So how many threads main is creating here? How many threads main is creating? Two threads. So one function thread 1 and another function is thread 2. Pthread underscore exit 0. Now can you tell me why I'm using pthread underscore exit here? Can you tell me why I'm using the pthread underscore exit here? Even though main thread is completed, subthreads will continue its job. Even though main thread is completed, will you agree subthreads will continue its job? Okay. Now the thing is, suppose this is in a while one loop. Suppose that is also in a while one loop. Suppose thread 1 is in a while one loop and thread 2 is also in a while one loop. Thread 1 is in a while one loop, thread 2 is also in a while one loop. Now will you agree these two threads can access this global array at a time? These two threads can access this global array at a time. There is no separate copy is created. That is a shareable data. Two threads can share the data. Now will you agree in this case we need a synchronization between these two threads. In this case we need a synchronization between these two threads. We need a synchronization between these two threads. So thread synchronization can be achieved using the concept called thread synchronization can be achieved using the concept called mutex. What is the full form of mutex? Mutual exclusive event. Mutex is nothing but mutual exclusive event. So thread synchronization can be achieved using the concept called mutex. So in this mutex concept, few functions are involved. I'll write the names of the functions. Again, I need to tell you, here I'm not going to write exact code, just rough code I am writing. So interview point of view also, so this type of discussion, maximum theoretical discussion only. Is it clear? So the functions involved in this mutex concept is pthread underscore mutex underscore init. The functions involved in this is pthread underscore mutex underscore init and pthread underscore mutex underscore lock and unlock. Pthread underscore mutex underscore init. Can you guess what it will do? Like this is like a semaphore only. Pthread underscore mutex underscore init. Can I say it will create mutex? Can I say it will create a, it will open and it will create a mutex? One integer, if I simply say as a C programmer, if I say it will create one integer in a kernel space somewhere, and you need to use pthread underscore mutex underscore lock, and you need to write some statements and pthread underscore mutex underscore unlock. In between lock and unlock, what we need to write? In between lock and unlock, what we need to write? We need to write a critical section of code. In between lock and unlock, what we need to do? Can I say we need to write a critical section of code? Observe. In between lock and unlock, we need to write a critical section of code. Now tell me, main thread, what it did? Main thread created a mutex, created mutex. What the main thread did? Can I say main thread is created a mutex? Will you agree? Main thread is created a mutex. After that, created two threads. After that, it is terminated. So in this program, whatever the rough code I written, main thread, what it is doing is creating the mutex and creating the two threads, and it is terminating. Can you tell me which lines those are? Again, can you tell me which, just a minute, which lines those are? Creating the mutex, creating the two threads, and terminated. Creating the mutex is line number 31. Creating the first thread is line number 32. Creating the second thread is line number 33. And it gets terminated. And it gets terminated using the pthread underscore exit. Now observe, suppose CPU time slice is given to the first thread first. Suppose CPU time slice is allocated to the thread 1. Now can I say this will block or unblock? Already resource is available. This will lock or unlock. Can I say it will waiting for the lock? Lock is already there. This function will not block. Can I say it will enter into the critical section of code? Suppose if I given a sleep of 30 seconds, can I say CPU time slice is shared to thread 2? Suppose if I give a sleep of 30 seconds, can I say the CPU time slice is shared to thread 2? Now you tell me in thread 2, this function will block or not? Now can you tell me in this thread 2, line number 21 will block or not? Can I say it will block? Why? Because already the mutex is locked by thread 1, because lock is not available. Now when the thread 1 is unlocked, when the thread 1 is unlocked, can I say this gets unblocked? When the thread 1 is releasing the key, when the thread 1 is unlocking, can I say thread 2 which is waiting for the lock, it will get the lock. Thread 2 which is waiting for the lock, it will get the lock. So this is the mechanism of mutex. This method is used to synchronize between the two threads when they are trying to access the common resource. Here, what is the common resource? Can you tell me? In this program, what is the common resource? Can you tell me? In this program, what is the common resource? Can you tell me? Can I say that array is a common resource? Will you agree that array is the common resource? Will you agree that array is a common resource? That array is the common resource. So this is how the thread synchronization can be achieved using the mutex. Any doubt in this? Please let me know. And this example programs you want, you can go through our material. So this is the theoretically I'm discussing. Is it clear? This is enough. So lock and unlock mechanism will be there. Now the question arises, what is the difference between the semaphore and mutex? Some of the interviews they will ask you, what is the difference between between semaphore and mutex? First is, both are synchronization mechanisms. Again, mutex and semaphore both are synchronization methods, synchronization mechanisms. Second point, semaphore is used between semaphore is used between two processes. Mutex is used between threads. Again, between threads which are in a single process. again both are synchronization methods, both are synchronization techniques. Semaphores are used between the processes, or mutex is used between the threads. And in a semaphore, in signaling mechanism will be there. Signaling means internally. Signaling means interrupt. In semaphore, signaling mechanism will be there. In semaphore, signaling mechanism will be there. In threads, in mutex, lock and unlock concept is there. In semaphore, signaling mechanism will be there. In mutex, lock and unlocking mechanism will be there. What is the meaning of this? Try to understand. What is the meaning of this? Try to understand. What is the meaning of this? Try to understand with one example, very simple example. Consider your offline class, your offline classroom door. Imagine classroom is a critical section of code. Imagine classroom is a critical section of code. A student wants to enter into the class via that door only the student need to enter into the class. Will you agree? If any student wants to enter into the class, attend the class via door only, they need to. Okay. Normally, you may know that in an offline class, we will not close from inside. Faculty will not close from inside the door. Will you agree? If you want to enter into the class, you have the rights to directly open the door, interrupt the faculty, and you can enter into the class. Again, I'm talking about semaphore concept. Semaphore is a signaling mechanism. So door is there to enter into the class. What is the critical section of code here? What is the critical section of code in this discussion? Can I say classroom is a critical section of code? If any student wants to enter into the classroom, he can open the door, he can interrupt, he can give some signal to the faculty that I am coming, he can enter it. Is it clear? That is a semaphore. Mutex means from inside faculty is locked the door. Mutex means from inside faculty is locked the door. Now you tell me. Mutex means from inside faculty is locked the door. Now tell me, when you enter into the critical section of code, what you need to do? What you need to do? You can't directly enter. You need to wait for, yes, you need to knock the door. You need to wait until the faculty unlock the things. You need to wait the faculty to unlock the things. So that is called as a mutex. In a mutex, definitely lock and unlock concept will be there. In a mutex, definitely locking and unlocking concept will be there. In a semaphore, signaling concept will be there. Have you understood this basic way, the difference? So, semaphore, signaling concept. Semaphore is used between the two processes, multiple processes, and what you called mutex between the two threads in a single process. Between the two threads in a single process, and in a mutex concept, locking and unlocking mechanism will be there. In a mutex concept, locking and unlocking will be there. Is that point is clear? So that is a concept of mutex, lock and unlock. After every lock operation, you must and should unlock so that others can lock it. After every lock operation, you must and should unlock so that others can lock it. Like you, very funny incident, very simple incidents I'll tell you. You entering into the washroom. Definitely that is a locking and unlocking concept. Yes or no? Yes or no? After every lock operation, there must and should be unlock operation. Then only others can lock it. Then only others can lock it. Another thread can lock it. When one thread is already locked, the mutex. Another thread is trying to lock that. Can I say that function will block? When one thread is already locked, if another thread is also trying to lock, which function will block? Can you tell me? One thread is already locked. If another thread is also trying to lock, which function will block the thread? Can I say pthread underscore mutex underscore lock. This thread will block until this thread gets unlock the mutex. This thread will block until this thread execution is blocked until the first thread unlocks the mutex. I hope you understood this concept. So the functions involved here is pthread underscore mutex underscore init, pthread underscore mutex underscore lock, pthread underscore mutex underscore unlock. Now if I ask you, nothing more to discuss here. Some examples are there. If you want, you can go through our material. If I ask you what is the advantage of the thread, first advantage is communication between the threads is easy. Second advantage is threads can execute faster compared to the processes. One of the student is asking what happens if one thread is locked, another process is trying to unlock it. BE8F1, another thread or another process? BE8F1, please, another thread. If another thread is trying to unlock, that unlock will not happen. That unlock will not happen until and unless that same thread unlocks it. Is that is clear? That purely depends upon the code what you are writing it. As per the standard process, first you should not unlock. First you need to lock, afterwards you need to unlock. Is it clear? Okay. Advantage of the threads we know. Thread communication is easy. Advantage of the threads you know. Faster in a work. Now try to think disadvantage of the thread. Suppose in a single process there are multiple threads are there. Thread 1, thread 2. Both are doing one work. Now tell me, if this thread is trying to access unauthorized memory, the entire process is going to be affected. If this thread, if one thread in a single process, if trying to access unauthorized memory, trying to do some illegal operation, can I say all other threads, entire process gets affected? Will you accept this statement? If one thread is trying to access unauthorized memory, if one thread is trying to access unauthorized memory, will you agree all other threads are going to affected? But if you think about the process, if one process is trying to access unauthorized memory, another process is not going to be affected. If one process is trying to access unauthorized memory, will you agree another process is not going to be affected? But whereas if one thread is trying to access unauthorized memory, the how many threads are there in the single process, all the threads are going to be affected. Is that point is clear? Because of one thread illegal operation, other threads are unnecessarily gets disturbed. Second disadvantage is memory. Will you agree? Here for this process 8 MB of a stack, for this process 8 MB of a stack will be there. But here these two threads need to share the same 8 MB of a stack. These two threads need to share the same 8 MB of a stack. So can I say if you create multiple threads in a single process, very soon memory shortage will come. Very soon memory shortage will come. Will you agree? In a single process, how many threads are there? For every thread, separate stack 8 MB is not created. Again, in a single process, if multiple threads are there, for every thread, separate stack is not created. All the threads need to share the same stack. Please try to respond it. So can I say limited memory will be there? This is one of the drawbacks. If you keep on creating the thread, if you are keep on creating the threads, can I say memory crisis comes for that process? So in this type of situations, threads is a better option or processes is a better option. In this situation, threads is the better option or the processes is a better option? Answer is processes is a better option. So these are some drawbacks of the threads. One is if one thread get disturbing get trying to access unauthorized memory, other threads are going to be disturbed. And second disadvantage is because of limited stack, because of limited stack, all the threads need to share the same stack. So then what happens is memory shortage will come. Memory shortage will come. Is that point is clear? This is about the threads. If you want to get more information, you can go through our material or additional information, more information. Is it clear? So this is about the thread concept. Next discussion will be on what? Next discussion will be on what? Memory management. Next discussion is on memory management. In this discussion, memory management, we are going to, in this discussion, we are going to discuss about the RAM. In this memory management, this is also entirely the theoretical concept. We are going to discuss about the RAM. Now, can you tell me what is the job of process manager? Will you agree? Process manager job is to manage the processes. What is the job of a signal manager? Signal manager job is to deliver the signal to a particular process. What is the job of resource manager? Resource manager job is to allocate resources. What is the job of the file manager? Will you agree? The job of the file manager is to manage the hard disk. Similarly, if you think about what is the job of memory manager job is to manage the primary memory. What is the meaning of primary memory? Memory manager job is to manage the primary memory. Primary memory means RAM. Now my question is, who is present in the RAM? My question is, who is present in the RAM? Can I say processes? who is present in the RAM? Will you agree? Processes are present in the RAM. Try to understand as simple as possible here. When the process manager is asking the memory manager, when the process manager is asking the memory manager that there is a new process is going to come, please allocate a memory in the RAM, then the memory manager should not say there is no space. Very simple words, try to understand. When process manager is asking the memory manager that when process manager is asking the memory manager that new process is coming and allocate a space in the RAM, then the memory manager should not say there is no space in the RAM. Like that, the memory manager need to manage the RAM space. If this point is clear, type C in the chat box. When process manager is asking the memory manager that I want some memory for upcoming process, memory manager need to manage the RAM in such a way that memory manager is to manage the RAM in such a way that memory manager is to manage the RAM in such a way that it should not say that there is no space for the upcoming process. We need to understand the policies, how the memory manager, the methods, how the memory manager is managing the RAM. Again, we need to understand the older system, older operating system, how the memory manager is managing the RAM, and the newer modern operating system, how the memory manager is managing the RAM. What is the difference between that management and this management? We need to understand. Again, we need to understand in older operating systems how the memory manager manages the RAM, and in a newer operating systems how the memory manager manages the RAM. We need to understand that policies, we need to understand that rules, we need to understand that procedure, we need to understand. So before that, we need to discuss one concept called, before that we need to discuss one concept called binding, address binding. Again, before that, we need to understand one concept called address binding. Now, will you agree? Suppose this is the RAM space. Suppose this is my RAM. It is having some addresses. Suppose 0x00000002, 0xFF. Suppose this is my RAM. These are the address locations. Now my question is, who will do the fetching and decoding and executing job? My question is, who will do the fetch? Who will do the fetching, decoding and executing job? Can I say processor will do the fetching, decoding and executing? What it will fetch? What it will fetch? Can I say opcodes? Again, B9P2, try to understand. What it will fetch? Can I say it will fetch opcodes, operational codes? It will fetch opcodes, operational codes. Suppose I written one program in my ADATOut, in my executable file, there are some opcodes are there. 0x12, 0xA3, 0xFF, 0x2B, like this some opcodes are there. I hope all of you know that opcodes are in a hexadecimal notation. In a microcontroller, you might have know this. opcodes are in a hexadecimal notation. Now my question is, these opcodes, these opcodes need to go and sit into the RAM some location. Once it is going and sitting into that location, the CPU will fetch from that location and it will decode and it will execute it. CPU will fetch from that location and it will decode and it will execute it. Again, these opcodes need to go and sit into some particular location in the RAM. Once these opcodes are going and sitting into one particular location in the RAM, they need to CPU need to fetch and need to execute. Now the question is, when this opcode knows it need to sit into this location, which location it need to sit? That is the discussion called address binding. Again, when the opcode knows where exactly, when that opcode knows where exactly it need to go and sit into the RAM location. So the binding between what and what we are discussing, the binding between the opcode and RAM location. I don't know you remembered or not, when we started with the library concept, we discussed the binding concept: static binding, dynamic load time binding, dynamic runtime binding. Can you tell me, if calling function gets the address of the called function at the time of compilation, the binding between them is called as, can you tell me, if calling function gets the address of the called function at the time of compilation, can you tell me that binding is called as a static binding? If calling function gets the address of called function at the time of loading, can you agree? Will you agree that is a dynamic load time binding? Dynamic load time binding. If the calling function will get the address of the called function not at compile time, not at load time, but if it is at runtime using the DL open, DL sim, DL error, so that binding is called as, if calling function gets the address of the called function at the time runtime, then that binding is called as dynamic runtime binding. I hope you might have remembered the functions involved in this. I hope you might have remembered the functions involved in this. There, the concept of calling function and called function. Here, the binding between what and what? Binding between what and what? Binding between what and what here? Here, the binding between opcode and address location. Here, the binding between opcode and the address location, where that opcode need to go and sit. Yes, opcode and RAM address. If suppose this opcode, where it need to go and sit, if it is decided at compile time, that is called as a static binding. If compile time only the opcode and the location where that opcode need to go and sit is decided by the compiler itself, if compile time only this opcode need to go into this location, this opcode need to go and sit into this location, if compile time only decided, then the binding between them is called as static binding. I don't know, you may know it or not, the raw codes, raw code. You might have done the microcontroller programming. You might have dumped the program into the microcontroller. So will you agree, at compile time only the address binding happens? You might have written org000h like this. Meaning is, in a cross compilers, what happens is, when the cross compilers are generating the hex file, this opcode need to go and sit into which location. At compile time only it is decided. Again, this opcode need to go and sit into which location. At compile time only it is decided. That is raw code. Is it clear? So in such case, how many times you dump your program into the microcontroller, every time these opcodes will get the same space, same address space, which is decided at compile time. No matter how many times you dump your code into the microcontroller, every time at compile time only the address binding happens. That is a compile time binding. One more thing is called, load time binding. Meaning is, compile time, compiler will not decide where this opcode need to go and sit, which location it need to go and sit. It is not decided at compile time. When it is decided, it is not decided at compile time. When it is decided, if it is decided at load time, such code is called as relocatable code. Note it down. If binding between, note it down, if binding between opcode and RAM location, if binding between opcode and RAM location is done at compile time, that code is called as raw code. That code is called as raw code. Suppose if binding between the opcode and the RAM location, if it is done at load time, then it is called, then that code is called as relocatable code. Relocatable code. If binding is postponed to runtime, means if the binding between the opcode and RAM location is decided at runtime, then that is called as executable code. Runtime, then that code is called as exe file, executable code. To achieve this, we need special hardware, that is MMU. Have you heard this? To achieve the runtime binding, we need a special hardware, that is MMU, memory management unit. To achieve this dynamic runtime binding, we need a special hardware that is called MMU. I hope some of you may know that this MMU will convert the logical address into the physical address. This MMU will convert the logical address, or we can call as a virtual address, into the physical address. So address binding concept we are discussing. There are three types of address bindings will be there between the opcode and location. One is called as compile time binding. Another is called as load time binding, and another one is called as runtime binding. Is it clear? So who will create a compile time binding addresses? Cross compilers will create. Example for load time binding is your .o file, object file. Example for load time binding is your object files. Example for runtime binding is your executable files. Again, example for runtime binding is your executable files. If this concept is clear, type C in the chat box so that we'll discuss about RAM organization, how the RAM is organized, how the RAM is managed. As I told you, RAM is one of the valuable resource in an operating system. RAM space is unnecessarily should not be wasted. Will you agree? RAM is one of the valuable resource. So RAM space is unnecessarily should not be disturbed it, wasted. So our main target of memory manager is to manage the RAM space in such a way that our main target of memory manager is to manage the RAM space in such a way that it should not waste the RAM, in such a way that it should not waste the RAM. So now what we need to discuss is in older versions of operating system, how the memory manager is managing the RAM. What is the drawback of that memory management? How it overcame all the things we need to discuss it. Again, in older versions of memory management, what is the policy the older versions of operating systems they followed for managing the RAM? What is the drawback of that management? How to overcome that? What is the new policy came? All these things we need to discuss it. Is that is clear? In older versions of operating system, memory manager followed a method called partitioning. Again, in older versions of OS, memory manager followed a method is called partitioning. So there are three types of partitionings will be there. One is fixed equal size partitioning. Another one is fixed unequal size partitioning and dynamic partitioning. Again, I'll repeat it. In older versions of memory manager, to manage the RAM space, they followed the method called partitioning. There are two types of partitioning. One is a fixed partitioning and another one is a dynamic partitioning. In a fixed, again two types of partitionings will be there. Fixed equal size partitioning and another one is fixed unequal size partitioning. fixed equal size partitioning, and another one is fixed unequal size partitioning. Again, in the older versions of operating system, the memory manager followed the method called partitioning, fixed equal size partitioning, fixed unequal size partitioning, and another one is dynamic partitioning. So what is the first we are going to discuss? Fixed equal size partition. In a fixed equal size partitioning, very simple concept, the RAM is divided into fixed sizes and each size is equal. RAM is divided into fixed sizes and all the sizes are same. Fixed equal size partitioning. Suppose it is a 8 MB. 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 Suppose it is also an 8 MB. The RAM is divided into fixed size and equal size. All partitions are equal size. RAM is divided into fixed size and all the partitions are equal size. This is the oldest method. Now can you tell me, if P1 process need 8 MB, can I say that 8 MB is allocated here? If P1 process need 8 MB, if P1 process need 8 MB, can I say that 8 MB is allocated for P1 process? This total 8 MB is allocated. For P1 process. Now tell me, if P2 process needs 6 MB, if P2 process need a 6 MB, can I say there is no 6 MB partition? So there is no other option. Even though it need a 6 MB, total 8 MB is allocated for P2 process. Now can you tell me how much of memory wasted here? 0 MB, here 2 MB. Suppose P3 process need 7 MB, even though 7 MB it required, 8 MB is allocated. Can I say here how much of 1 MB wasted? Suppose P4 process need 4 MB, even though 8 MB is allocated, can I say 4 MB wasted here? Now can you tell me total how much of wastage of memory here? P1 process required how much of MB? P1 process required how much of MB? 8 MB. How much of memory is allocated? 8 MB. So 0 wastage. P2 process needs 6 MB, allocated 8 MB. So 2 MB gets wasted. P3 process needs 7 MB, but allocated 8 MB, 1 MB wasted. P4 process need 8 MB, but P4 process need 4 MB, but allocated is 8 MB. Can I say 4 is wasted? 4 plus 2, 6 plus 1, 7 MB is wasted here. In this method of policy, in this policy, in this fixed equal size policy, in this fixed equal size partitioning, this much of internal memory gets wasted. Will you agree this? Please try to respond it. Will you agree this? Fixed equal size partitioning. To overcome that, one more policy introduced, that is fixed unequal size partitioning. To overcome this internal memory wastage, they introduced one more policy, that is fixed unequal partitioning. All partitions are fixed size, but what is it? All partitions are fixed size, but can I say unequal sizes? Suppose it is a 8 MB. Suppose it is a 8 MB. Suppose it is a 4 MB, 4 MB, and 2 MB, 2 MB. I hope all of you are following this. This is the older versions of memory manager. This is the older versions of memory manager policy. They manage the RAM size like this. It's clear? Now tell me, the same situation, P1 process need 8 MB, for P1 8 MB is given. P2 process needs 6 MB, so there is no 6 MB. Can I say 8 MB is given? P3 process needs 7 MB. Now the question arises, it needs 7 MB, there is no 7 MB, maybe the chance of giving 4 plus 4, 2. Can I say here also 1 MB wasted? Suppose this is a 4 MB, P4 process need 4 MB, can I say 4 MB is allocated? Now compared to this policy, in this policy, internal wastage is less. Compared to the fixed equal size partitioning, in a fixed unequal size partitioning, internal wastage is less. Yes or no? In this second policy, all the partitions are fixed and unequal sizes. So there is a chance of less wastage of memory. Here I need to talk one term called internal fragmentation. Here I need to talk one term called internal fragmentation. Again, here I need to use one term called internal fragmentation. In a fixed partitioning method, answer is, question is what is internal fragmentation? Answer is, in fixed partitioning method, a process may get more memory than what it required. That additional wastage of memory, additional memory is called as internal fragmentation. Again, in a fixed partitioning method, a process may get more than what it required. The process may get a memory more than what it required. That additional memory which is wasted, unnecessarily allocated, so that concept, that memory is called as internal fragmentation. Can you tell me, in these two methods, in these two cases, suppose this is the not a 4 MB, suppose just give me 1 minute of time, suppose this is also 8 MB, suppose this is the 6 MB, this is the 4 MB, this is the 2 MB. I'll write it here. This is the 6 MB and this is the 4 MB, that is a 2 MB. 6 MB, 4 MB. Now tell me, in this policy, for P1 process, how much of internal fragmentation? 0. For P2 process, 0. For P3 process, 7 it required, 8, 1 MB. For P4 process, 0. Now tell me, in these two methods, fixed equal size partitioning, fixed unequal size partitioning, in which method internal fragmentation is more? In these two policies, in these two methods, in which method the internal fragmentation is more? Can I say fixed equal size partitioning, fixed equal size partitioning, fixed equal size partitioning, internal fragmentation is more compared to the fixed unequal size partitioning. To overcome this, they introduced one more policy. To overcome this, they introduced one more policy that is called dynamic partitioning. Again, to overcome this, they introduced one more policy that is called dynamic partitioning. Now, can you tell me what happens in the dynamic partitioning method? Can you tell me what happens in the dynamic partitioning method? In a dynamic partitioning method, how much a process required, that much of memory is allocated. Again, in this new policy, dynamic partitioning method, how much a process required, that much of memory is allocated. Can I say there is no chance of internal fragmentation in this policy? Again, in a dynamic partitioning method, how much a process required, that much of memory is allocated. Now, let's understand with this diagram. P1 process, how much of memory it required? Can you tell me P1 process, how much of memory it required? In this example, P1 process, how much of memory it required? 8 MB. Can I say 8 MB is allocated for P1 process? 8 MB for P1 process. P2 process, how much of memory is required? 6 MB. Can I say 6 MB is allocated? P2 process. P3 process, how much of memory is required? 7 MB. Can I say 7 MB is allocated for P3? P4 process, how much of memory is required? 4 MB. Can I say 4 MB is allocated for P4? Suppose 10 MB is free. Suppose 10 MB is free here. Now, can you tell me here, is there any internal wastage? Is there any internal fragmentation? In this method, in this policy, is there any internal fragmentation? No, right? Now tell me, how much of memory P1 is occupying here in this particular example scenario? 8. P2, 6. P3, 7. P4, 4. How much of MB is free? How much of MB is free? How much of MB is free? 10 MB. Suppose P1 is completed. Suppose P1 is done with their job. Suppose P1 is done with the job. Now tell me, total 10 plus 8, total how much of MB is free? 10 plus 8, 18 MB. Suppose P5 process came, it required 12 MB. Suppose P5 process came, it required 12 MB. Now tell me, total 12 MB is free or not? 10 plus 8, totally more than 12 is present. But will you agree, contiguously 12 is not available? P5 process came which required 12 MB. So 10 MB is one place, 8 MB is another place. So contiguously 12 MB is not there, but total 8 MB is there. This situation is called as external fragmentation. This situation is called as external fragmentation. Able to understand this scenario? Here there is no problem, there is no internal fragmentation. Internal fragmentation solved, but new problem is arised, that is external fragmentation. For this process, it required 12 MB, total 10 plus 8, 18 MB is there, but unfortunately the 12 MB is not in, unfortunately the 12 MB is not in, unfortunately the 12 MB is not in contiguous. So that situation is called as external fragmentation. Question is, what is external fragmentation? Question is, what is external? What is external fragmentation? Answer is, for a process, answer is, in dynamic partitioning method, in a dynamic partitioning method, for a process, memory is available but not in contiguous, but not contiguous. So this is called as external fragmentation. This is called as external fragmentation. So now you tell me, in this example, P5 process need how much of MB memory? In this example, P5 process 12 MB, but how much of MB is free? How much of MB is free? 18 MB. But what is the problem here? What is the problem here? That 18 MB is not contiguous. So that is the reason P5 process cannot execute. That is the reason P5 process cannot execute. That is the reason P5 process cannot execute. Can you tell me some solutions? The solution is, this P2 process, if you move here, P3 process, if you move up, can I say we can adjust the space here? Is it clear? The solution is, all the running processes, if you move at one side, you can arrange the space at another side. If all the running processes, if you make it one side, if all the running processes, if you make it one side, all the running processes, if it is shifted at one side and new space, all the running processes is shifted at one side, new space is arranged at another side. So this is how the P5 process can get a space to execute. This is how P5 process will get a space to execute. But the problem here, running processes should be stopped for a while. But the problem here, running processes should be stopped for a while. Can I say? Now, when a running processes are stopped for a while for getting a new space, throughput suffers. Do you know? In a process management, we discussed one term called throughput, number of processes completed per unit of time. Now tell me, throughput is more is a good environment or throughput is less is a good environment? Can you tell me, throughput is more is a good environment, throughput is less is a good environment? Throughput is more is a good environment or throughput is less is a good environment? Can I say throughput is more is a good environment? Will you agree throughput is more is a good environment? Now here, why throughput is going to suffer? Why throughput is going to suffer? Can you tell me all the processes, will you agree that all the processes are going to get new space? Will you agree? All the processes, this process will get a new space, this process will get a new space, this process will get a new space. Can I say all these processes should be stopped for a while? Execution should be stopped. Will you agree throughput suffers? Try to answer it, yes or no? Will you agree in a fixed partitioning method, fixed equal size partitioning, lots of internal fragmentation? Fixed equal size partitioning, lots of internal fragmentation. To overcome that, fixed unequal size partitioning, compared to the equal size, here less internal fragmentation, but still there. To overcome that, they introduced one more policy, dynamic partitioning. In a dynamic partitioning, one problem is solved. Internal fragmentation problem is solved. But new problem came. What is that? But new problem came. What is that? External fragmentation. External fragmentation. To overcome that external fragmentation, they introduced one policy called defragmentation. Anybody done the defragmentation for your hard disk in your laptop? Anybody done the defragmentation to your hard disk? In a hard disk, when you do the defragmentation, all the free space is made at one side of the disk. All the files will be moved into another side of the, all the files are moved into another file, another space of the disk. Now here also the same thing. Defragmentation is happening to a process. All the running processes should be shifted at one side. Free space is made at another side. Again, all the running processes are made at another one side and free space is made at another one side. The problem with this is running processes should be stopped for a while. The problem with this is running processes should be stopped for a while. So to overcome this, In a defragmentation method also problem is there. To overcome this, they introduced new policy and new method to manage the RAM space. That new policy and new method called paging, segment, demand page, MMU, logical address, physical address, and all other things are introduced. In a tomorrow session, we'll discuss it. Is it clear? To overcome this internal fragmentation, to overcome this external fragmentation, to overcome this defragmentation, they came up with a new idea, new methods, new policies. Tomorrow we need to discuss about that. Is it clear? I'm going to wind up the today's session. Tomorrow we'll discuss those concepts. Tomorrow 2 o'clock is my session. Is it clear? Tomorrow 2 o'clock I'm going to discuss it. Tomorrow 1 hour session will be there. I'm going to wind up the Linux concept. Is it clear? Tomorrow 1 hour session will be there. I'm going to wind up the concept of Linux. Thank you very much for attending.